So continuing from the yesterday's lecture, what we saw yesterday was the various properties of a solid that are needed to be understood and evaluated while designing a CAD model or while preparing a CAD model. Now, when you develop a CAD model, it is very important that you understand what is the orientability of the surface. And Mobius rule is the rule that is generally employed in order to understand the orientability. Now, for every surface that you have got, every surface has to have one basic property, that is the surface has to be in a closed loop. All the surfaces have to be in a closed loop. And the closing of the loop has to be in what we call as the anti-clockwise direction, that is this direction. So if the arrow is plotted, if an arrow is going to be plotted, then the tail of the preceding arrow should connect to the head of the tail of the succeeding arrow should meet the head of the preceding arrow. So this is how the orientability is going to be plotted, and that is how orientability is understood. So for any surface or any model which is closed and orientable, Mobius gave a very simple and straightforward rule that all the surfaces, for any surface, all the surfaces, the loop has to be complete, and most important aspect, for an edge that is shared between two surfaces, the edge that is shared between two surfaces, the orientability will be opposite in direction at both the surfaces. The orientability will be opposite at both the surfaces along the shared edge. So this edge is shared edge. So if I look at this surface, this is the orientability that I'll get, and at this surface, this is the orientability that I'll get. So if I start to plot the orientability over here, so this is the direction of orientability, whereas for the same shared edge on the opposite surface, the orientability is in the opposite direction. And this holds true, and this is going to hold true for all the shared edges, So the Mobius rule states that for a surface to be orientable, every shared edge between the two surfaces must have opposite orientability. Okay? Every surface that is being shared through a shared edge will have opposite orientability for that edge along different surfaces. So this is the Mobius rule of orientability. Now, what is a manifold? So manifold is basically a local shape which can describe the topology of the geometrical entity. A local shape which can define the topology of the geometrical entity. Like if you have got a curve like this, now how to define this curve with a local entity? What I can define is that it is a straight line having 2 points, 2 corner points, P1 and P2, and these are the same corner points, that is P1 and P2. So these two surfaces are actually they are called as the surface manifolds. Okay. So there are many different classifications. There is a single manifold or one manifold. Like this is a very classic example of one manifold that I have just given, where a curve has been converted into a straight line. That is one manifold. Then there are two manifolds also available. So this is torus is a very good example of two manifold. Okay. So torus is an example of two manifold. And then there is another surface which we call as a three manifold. And three manifolds are those surfaces where you have got a mating surface. So a manifold can be along the edge. It can be along the face also. If you create two cubes on the same face. Okay. So this is called as the surface manifold. While this example is called as the edge manifold. And then there is another thing which we call as a point manifold. We also called it as a point manifold. Okay. So there are three different classifications over here which can be interpreted in that sense. What you have to understand is However, when you look at edge manifold, can you tell me what is the problem with this figure? What is the problem with this figure? Can anybody just tell me what is the problem with this figure? There is something wrong, which is breaking the rules of CAD model. Any idea?
So the intersection may have zero volume almost.
No. The problem is that this plane and this plane are actually intersecting each other at this point. So what is happening is the two planes are actually intersecting each other. While when we read the definition of a CAD model, the curves or the surfaces have to be non-self-intersecting. But here what you are finding is that these surfaces are getting intersected. So this is a very classic case where a valid CAD model is actually not going to work when you process it in the softwares, because it is violating one of the basic rules of CAD. That is, the surfaces are intersecting each other. Now, how do we evaluate the CAD model? How we evaluate the CAD model? Now, evaluation of the CAD model is generally done for the topological validity. Okay? It is not done for geometrical validity. It is only done for topological validity. And Euler-Poincare came up with a very simple formula based on the geometrical entities or the features that are there in the model. This is a very standard formula. This is the most standard formula. V stands for vertices, E stands for edges, F stands for faces, L stands for loops, S stands for solid, and G stands for genus. Is it clear? I'll just repeat it once again. V is for vertex, E is for edges, F is for faces, L is for loop, F again goes for faces, S goes for solid, and G goes for genus. So you already know what is genus, you already know what is vertex, you know what is edges, and you know what is faces. I told you yesterday. So today what I'll explain to you are these two properties, that is loops and solids. So what is a loop? Loop basically stands for orientability. The loop is basically defining the orientability. If a particular face that you have constructed with the help of vertices and edges is orientable, then the number of loops on that face will be equal to 1. Okay? Solid basically S basically reflects a solid, which basically means that the whole surface is a single entity. The whole object is a single entity. So that is the formula for solid. So generally the value of S will always be between 1. It will be either 0 or it will be 1. If you find that it is not a topologically valid thing, generally the value of S will be 0. Otherwise the value of S will be generally 1. Okay? So this is the formula that we need to apply. So let us take a very simple example. There is a cube. In figure A, there is a cube. Now let us start counting all the features. So what features we need? We need vertices, we need edges, we need faces, we need loops, we need genus, and we need shell or solid. Okay? So let us start counting. How many vertices are there?
8 vertices.
8 vertices. Okay? So vertices become equal to 8. How many edges are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. So there are 12 edges. Okay? How many faces are there?
6.
6 faces are there. That is very easily understood. Now, since there are 6 faces, on each face there will be an orientability. Okay? So how many orientability curves are there? 6. Okay? And since it is a single solid, so the value of shell or value of solid, that is the S value, is equal to 1. The value of S is equal to 1. Now let us substitute it in this formula. Let us substitute this in the formula. Okay? So you already know what the values are. So let us put it. How many vertices were there? 8. How many edges? 12. How many faces? 6. Minus how many loops? 6. Minus how many faces? 6. Minus 2 times how many shells? 1. Is there any genus available in
No,
this
sir.
figure?
No, sir.
There is no through hole, so genus is equal to 0. Now what will be the value? So it is 8 minus 12 plus 6 minus 0 minus 2. So it is 12 and 2 14, and 8 and 6 is equal to 14. So this value becomes 0. So LHS is equal to RHS. That means this object that you have just evaluated is topologically valid. This object is topologically valid. Okay? Now let us move to the second object. In the second object, what has happened is there is a hole at the top. There is a square hole at the top. And that hole is penetrating to the half of the depth. It is penetrating to half of the depth. Okay? So now how many vertices are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So how many vertices are there? 16 vertices. Understood everybody, or any doubts? How I got 16?
Understood, sir.
Everybody?
Yes, sir.
Okay. Now let us start counting the edges. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11.
So say front row.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 edges. Okay? Similarly, after 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24. So there are 24 edges now. Clear? How I got the edges?
Yes, sir.
Yes, sir.
Okay.
Yes, sir.
Now let us go to the third part. How many faces are there? So face number 1, face number 2, face number 3, face number 4. This is face number 5. Bottom is face number 6. Now this is face number 7, face number 8, face number 9, face number 10, and the bottom is face number 11. Okay, top is open, so there is no face at the top. Have you understood? The top is open, so there is no face at the top. It is open. So 6 on the outer cube and 5 on the inner cube, you get 11 faces. Is it clear?
Yes.
Yes, sir.
Okay. Now once you have done vertices, edges, faces, genus is equal to
0.
0. Good. Shell is equal to
2.
Why 2? Is it a single solid, or there are two different solids?
Single volt.
So S is equal to 1. Why S is equal to 1? Because what you did was you created a square and you extruded it to some depth. So the solid remains single. The solid has
Yes.
not changed. There are no two solids over here. So the value of S is 1 and G. Now we have to come to loops. Now let us start searching for loops. Loop number 1, loop number 2, loop number 3, loop number 4, loop number 5, and loop number 6 for the outer cylinder. Got my point? So there are 6 on the outer cube, Similarly, how many loops are there in the inner cube? 1, 2, 3, 4, 5, 6. So there, how many cube loops are there? There are 12 loops. Now this is something that is not this is where maximum mistakes happen. So if you have any doubt, please ask me again. I'll explain this, because after that you are going to do it on your own. The next figure you are going to do it on your own. So if you have any doubt, please ask me.
So loop एक बार define कर दीजिए.
देखो, लूप क्या होता है? ओरिएंटेबिलिटी ऑफ द एजेस. ठीक है, तो फ्रंट, राइट एंड लेफ्ट साइड, बैक एंड बॉटम इज क्लियर टू यू.
Yes sir.
द प्रॉब्लम इज ऑन द टॉप सरफेस. इस टॉप सरफेस पे है क्या? अगर हम ध्यान से ऊपर से देखें तो हमको ये दिखाई देगा. हमें क्या दिखाई देगा? दो हैं क्यूब, एक क्यूब आउटर, एक क्यूब इनर. ठीक है ना? तो ये जो इनर है ये क्या है? ये इनर बाउंड्री है और ये आउटर बाउंड्री. तो कितनी बाउंड्रीज हो गई इस सरफेस पे, टॉप सरफेस पे?
So 2.
दो बाउंड्रीज हो गई. तो आउटर बाउंड्री का एक अपना लूप होगा
Yes sir.
और इनर बाउंड्री का एक अपना लूप होगा.
Yes sir.
ठीक है ना? क्योंकि बाउंड्री डिटर्मिनिज्म जो पॉइंट था कैड मॉडल का, वो क्या डिफाइन करता है? वो ये डिफाइन करता है कि सारे सॉलिड पॉइंट्स इसके बीच में आने चाहिए. तो अगर हम इंटरनली हॉलो सरफेस बना रहे हैं तो एक इंटरनल बाउंड्री होगी, एक एक्सटर्नल बाउंड्री होगी. ये तो इसलिए टॉप सरफेस पे कितने लूप्स बने?
2 sir.
2. ठीक है, बाकी 5 सरफेस बाहर थे और 5 सरफेस अंदर है. तो 5 और 5 10 सरफेस अंदर और बाहर हो गए,
और 2 12. Yes sir.
2 ऊपर के सरफेस पे आ गए. तो कितने लूप्स बन गए? 12. अब चलिए इसको फिर से रखते हैं इक्वेशन में. इक्वेशन क्या है? v माइनस ई प्लस एफ माइनस एल माइनस एफ माइनस 2 टाइम्स एस माइनस जी. चलिए, 16 माइनस 24 प्लस 11 माइनस लूप इज 12 माइनस 11 माइनस 2 1 माइनस 0. 16 माइनस 24 प्लस 11 माइनस 1 माइनस 2 कितना हुआ? दैट इज 27 माइनस 27 इक्वल टू 0. ठीक है, which means that this surface or this solid model is also topologically valid. Now what I want you to do is, without going through this, you try to solve this problem within 2 minutes. Not more than 2 minutes are needed to solve this. ठीक है, try to solve in 2 minutes.
What is this?
Try to solve this C in 2 minutes.
What is this? Huh?
If you have any doubt, ask me. If anybody has doubt, please do not hesitate to ask. Verify whether I have what I have mentioned over here: 16 vertices, 24 edges, 10 faces, 12 loops, and 1 hole is true or not. First of all, you verify that.
10 faces. 6 टेस्ट हो गए. 7 बस. ऊपर का एक खाली है. लूप्स. 1 2 3 4 5 की जगह 1 2 5 10 और 2 12. होल है 10 फेसेस. 1 2 1 2 3 4 5 6
Verified? Verified or not? जल्दी बोलिए हाँ या ना.
Yes, sir, it's right.
सबने वेरीफाई किया है?
Yes, sir.
चलिए शुरू करते हैं। सबसे पहले आते हैं वर्टिसेस पे। 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 16 वर्टिसेस। ठीक है, अब आते हैं एजेस पे। 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24। ठीक है, अब आते हैं फेसेस पे। फेसेस आइडेंटिफाई करने के लिए आपको एक चीज सबसे पहले क्या समझनी होगी कि दिस होल दैट इज गोइंग इनटू दिस CAD मॉडल इज अ थ्रू होल। ठीक है, सो फेस नंबर 1 2 बैक फेस 3 4 टॉप फेस 5 बॉटम फेस 6 और अंदर हो गया 7 8 9 एंड 10। ओनली 10 फेसेस आते हैं। अंडरस्टूड?
Yes,
Yes,
sir.
sir.
So there are 10 faces. अच्छा, लूप्स 4 बाहर के लूप हो गए, 4 अंदर के लूप हो गए। ठीक है, 8 ऊपर कितने सरफेस, ऊपर कितने लूप्स होंगे?
2 सर,
और नीचे
2
2
तो हो गए
12
12.
और चूंकि इट्स अ थ्रू होल, दिस इज अ थ्रू होल, सो G is equal to 1.
1.
Now in 10 seconds verify this.
And 2 minus 12
Verified?
यस सर,
sir.
ठीक। अच्छा, अब आते हैं इस ऑब्जेक्ट पे। क्या ये वैलिड CAD मॉडल है? क्या ये वैलिड CAD मॉडल है? पहले ये क्वेश्चन है।
No, sir.
क्यों?
सर प्लेन इंटरसेक्शन हो रहा है सर। एक ये जो टॉप वाला प्लेन जो एक्सटेंडेड वाला है वो।
इसको
और-
बोलते हैं डैंगलिंग प्लेन।
यस
So for a CAD model, there should not be either a dangling edge or a dangling plane, है ना?
यस
But what I want you to do right now is I want you to verify the Euler Poincare formula for this figure also. I want you to verify the Euler Poincare formula for this figure also. So I am writing down the features. You will tell me the values. How many vertices?
8 से यहीं पे है 9 10
8 sir.
10, sir.
सर
10.
10 कंसीडर करेंगे।
1 2 3 4 5 6 7 8 9 and 10. Edges?
11.
12
12 edges
1 2 3 4 5 6 7 8 9 10 11 12 13 14 15.
yes to 15
How many faces?
6
7.
7
Pakka 7.
यस सर 6 उसमें क्यूब में और एक डैंगलिंग वाला।
Loops?
1 2 3 4 5 6
7, sir.
Huh?
7 होगा वो भी।
6 और इसका भी और
Solid?
कंसीडर 7
Solid? Solid कितना होगा? S की वैल्यू
1 होगा।
1 होगा।
So 1.
हाँ 1 ही होगा। और g की वैल्यू
0.
So
0।
0.
अब जरा वेरीफाई करो इसको। Are you getting 0?
Yes, sir.
तो इसका क्या मतलब हुआ?
So कोई कंजक्शन होगा जहाँ पे ये सिर्फ इस कंडीशन में वर्क कर रहा हो।
इसका मतलब क्या हुआ? We know that this is not a valid CAD model, है ना?
Yes. Hmm.
But it is coming out to be topologically equivalent. तो इसका मतलब क्या हुआ? इसका मतलब ये हुआ कि यूलर पॉइंट केयर फॉर्मूला doesn't look into the features of CAD optimality. That is, if a Euler point care formula is satisfied, it doesn't mean the model will be a valid model. It only means that the topological equivalence has been established. The validity of the CAD model is basically defined by the 6 basic principles that we defined earlier, where we are looking into the boundary determinism, homogeneous, three-dimensionality, non-self-intersecting, and no additional loops or additional features extending out of the body without closure. ठीक है? So it means Euler point care formula can give you a topological equivalence, but it will not be able to give you any information regarding the validity of the CAD model. The validity of the CAD model is only going to be defined with respect to the basic principles of solid model. ठीक है? So why are we using Euler point care formula? Why are we using the Euler point care formula?
So to check whether the topological equivalence is there or not.
Equivalence can be established or not.
Yes.
ठीक है? That's it. Nothing else. आप इसमें अगर equivalence है, you will never say that the model is a valid. You will only say that the topological equivalence has been established, but the validity of the model has to be checked with respect to the basic principles of solid models. So that was all about the basic solid modeling. Now I am moving on to the processes of doing solid modeling. How do we develop a solid model? So when you use your solid modeling softwares, maybe Pro or SolidWorks, there are different algorithms which are actually working at the back end when you simply perform some operations. Like you open the software, you want to make a cube. Okay, so what you do is you create a square or a rectangular shape on the bed, and then you type a command extrude. Before that, you use a command line. You pick up a point. So all these commands are happening, but what you need to understand is what is happening at the back end, which is actually going to generate the image as per your requirement. So one of the most basic processes that was used initially was called as primitive instancing, which was one of the earlier methods in order to develop a solid model. Now, when we use primitive instancing, it's a very simple method actually. The idea is primitive. Using primitives, we use instancing or developing the model. So in a mathematical form, can anybody explain to me what is a primitive? What is a primitive? Is a point a primitive? Is a point in an open space or three-dimensional Euclidean space, is it a primitive? Yes or no? What is a line?
collection of points.
It's not a collection of points. It is the shortest distance between 2 points.
Yes, sir.
It's not a collection of points. ठीक है? It's the shortest distance between 2 points.
Yes, sir.
So how is the line being defined? How is the line being defined? A line is being defined with the help of points P1 and P2. So in this case, these points become primitives. Suppose you have an open-ended curve, P1 and P2. These are the points. It starts from P1 and ends at P2. So this is the curve. What is the difference between these two? What is the difference between these two? Or is there no difference?
सर हम P1 या P2 को एक्सटेंड करेंगे तो सर कभी इंटरसेक्ट होने के चांसेस नहीं है, बट अगर कर्व में अगर मैं एक्सटेंड करता हूँ पॉइंट्स के आगे तो शायद इंटरसेक्ट कर सकते हैं.
You didn't understand what I asked. My question was, what is the relation between this curve and this line? Can you identify a relation between this curve and a line?
सर अ मैथमेटिकल रिलेशन और मतलब ऑब्जर्वेशनल.
अब आप खुद दिमाग लगाओ. I have already explained what I wanted. I have already given my answer also. I think you should be able to pick out now.
सब कर्व को अनफोल्ड कर देंगे तो वो लाइन बन जाएगी.
Yes. अगर हम कर्व को अनफोल्ड कर देंगे तो क्या हो जाएगा? एक लाइन बन जाएगी. P1 P2 ये मैं पहले भी पीछे समझा चुका हूं. ठीक है. तो बेसिकली ये क्या है, चाहे ये कर्व हो चाहे ये लाइन हो, इसको हम डिफाइन कैसे कर रहे हैं? इन पॉइंट्स P1 और P2 की डेफिनेशन से. What is a line? Line is the shortest distance between point P1 and P2. What is a curve? A curve is a path being traced starting from point P1 and ending at point P2. तो इस कर्व को डिफाइन करने और इस लाइन को डिफाइन करने में हम कौन से बेसिक्स यूज कर रहे हैं? पॉइंट्स P1 एंड P2. इसका मतलब ये है कि ये कर्व और ये लाइन, दे आर पार्ट ऑफ अ सिंगल फैमिली. ठीक है, समझ में आया?
यस सर.
इसका मतलब क्या है? प्रिमिटिव इंस्टेंसिंग का मतलब क्या है? अब मैं यहां से समझाता हूं. प्रिमिटिव इंस्टेंसिंग का मतलब होता है कि अगर हमें किसी ऑब्जेक्ट को डिफाइन करना है, जैसे ये सिलेंडर था, इस सिलेंडर को डिफाइन करने के लिए मेरे को सिर्फ 2 पैरामीटर्स की जरूरत है. एक आर की जरूरत है और एक हाइट की जरूरत है. ठीक है. इसी तरीके से अगर मेरे को एक सर्किल को डिफाइन करना है तो सर्किल को डिफाइन करने के लिए मुझे सिर्फ आर की जरूरत है. तो इस सिलेंडर और इस सर्किल के बीच में मैं एक रिलेशनशिप बना सकता हूं. क्या कि अगर मैं एक आर वैल्यू को डिफाइन कर देता हूं, तो बेसिकली मैं एक फैक्टर डिफाइन कर रहा हूं और उस फैक्टर से मैं किसी भी ऑब्जेक्ट को रिक्रिएट कर सकता हूं. ये दोनों एक फैमिली के हिस्सा हो सकते हैं. क्यों? क्योंकि दोनों के आइडेंटिफायर सेम है. तो प्रिमिटिव इंस्टेंसिंग में बेसिकली हम करते क्या है? प्रिमिटिव इंस्टेंसिंग में हम क्या करते हैं? हम पहले एक जेनेरेटिक प्रिमिटिव ढूंढने की कोशिश करते हैं. जैसे यहां पर हमने क्या जेनेरेटिक प्रिमिटिव ढूंढे थे? पॉइंट्स P1 और P2. अगर ये जेनेरिक प्रिमिटिव्स एक ही फीचर जो कि एक पॉइंट है, कई डिफरेंट ऑब्जेक्ट्स को या कई डिफरेंट क्लास ऑफ ऑब्जेक्ट्स को आइडेंटिफाई कर सकता है, तो वो डिफरेंट क्लास ऑफ ऑब्जेक्ट्स बन जाते हैं एक फैमिली, और उस फैमिली के आइडेंटिफायर बन जाते हैं ये वैल्यूज. तो अगर अब मुझे कर्व और इसको डिफाइन करना है, लाइन को या कर्व को डिफाइन करना है, तो ये दोनों क्या है? दे आर फंक्शंस ऑफ P1 एंड P2. चाहे लाइन को डिफाइन करना हो चाहे कर्व को डिफाइन करना हो, दे आर फंक्शंस ऑफ P1 एंड P2. तो प्रिमिटिव इंस्टेंसिंग में हम जब करते थे तो प्रिमिटिव इंस्टेंसिंग में सबसे पहले हम ये आइडेंटिफाई करते थे कि जैसे हमने ये शेप लिया, ये ऑब्जेक्ट लिया, अब इस ऑब्जेक्ट को हमने डिफाइन करने के लिए हमें क्या क्या पैरामीटर्स की जरूरत है, हमें क्या क्या पैरामीटर्स की जरूरत है। तो हमको एक बड़ा डायमीटर है जिसको हम D3 करें, एक उससे छोटा डायमीटर है जिसे D2 करें, और एक उससे छोटा डायमीटर है D1। तो हमने वो तीनों फैक्टर्स ले लिए, और हमको क्या चाहिए, दो हाइट्स है H1 एंड H2, वो हमने यहां पर आइडेंटिफाई कर दी। और क्या फैक्टर है, ये विड्थ W और ये लेंथ L, जिसमें कि ये कट सेक्शन लगेगा। अब इन फैक्टर्स को आइडेंटिफाई करने के बाद अगर हम कुछ भी ऐसा ऑब्जेक्ट बनाते हैं जिसमें ये फैक्टर्स यूज होते हैं, यही फैक्टर्स यूज होते हैं, देन दे बिकम अ क्लास ऑफ फैमिली। बट देयर इज अ प्रॉब्लम, जो कि अभी इस क्लास में भी हमने देखी। द प्रॉब्लम इज द आइडेंटिफिकेशन ऑफ अ फैमिली, दैट इज द बेसिक प्रॉब्लम। While writing an algorithm, you have to put up computing properties for different shapes, different parameters, and different structures. हर आदमी के लिए विजुलाइज करना और विजुलाइज करके उस चीज को अंडरस्टैंड करना कि जैसे ये शेप है एक, अगर मैं एक शेप बनाता हूं, ये शेप बेसिकली किसको रिप्रेजेंट कर रहा है, हर व्यक्ति के लिए ये आइडेंटिफाई करना इतना आसान नहीं है। क्या ये स्क्वायर शेप पिरामिड है, क्या ये रेक्टेंगुलर शेप पिरामिड है, क्या ये कोन है, हर एक के लिए विजुलाइज करना आसान नहीं है। इसीलिए कैड मॉडलिंग में या कैड में विजुलाइजेशन को इतनी इंपॉर्टेंस दी गई थी। तो पॉइंट ऑफ ऑब्जर्वेशन के हिसाब से लोग अपने अपने तरीके से इसे विजुलाइज कर सकते हैं, और इसकी सबसे बड़ी प्रॉब्लम क्या हो सकती है कि एक ही फिगर के कई सारे अलग अलग कोड्स तैयार किए जा सकते हैं, कई अलग अलग कोड्स तैयार किए जा सकते हैं बेस्ड ऑन हिज ओन विजुअलाइजेशन ऑफ द प्रोडक्ट। दैट इज द प्रॉब्लम विद प्रिमिटिव इंस्टेंसिंग, एंड the number of primitives that may be needed will also be sometimes very huge. Like if you go into this figure, if you go into this object itself, now how will you define H1 and H2? H1 and H2 will be defined with respect to points, different points. Now this one is a linear, this one is a vertical height, this is an angular height. So you need to convert this into some sort of geometry and get the value somehow. ठीक है? So H1 should more be reflected like this as H1. So understanding the image and extracting the data out of it is not that simple, and that is why primitive instancing was initially developed but never followed it. Nobody followed it up, because the basic problem that a same object can be viewed in a different way by different person makes it completely unviable. Next comes a method of which we call as half spaces. Now this method again is something which is very typical to understand. As we have already understood, what is a solid model? A solid model is something that is going to be developed in a three-dimensional Euclidean space which is defined. ठीक है, आपकी जो कंप्यूटर की स्क्रीन होती है, उस स्क्रीन की बाउंड्रीज हम डिफाइन करते हैं, उस स्क्रीन की बाउंड्रीज को हम डिफाइन करते हैं, हम एक रेंज उसकी डिफाइन करते हैं। सो whatever we are making in an three-dimensional Euclidean space, but that three-dimensional Euclidean space is a defined space. So that is the first thing. Now half spaces, basically what half spaces do is that you take a model, and that model is first broken up into two sections. It is broken up into two sections. The two sections are the boundary and the interior. That is going to constitute your CAD model. Okay. Now, first of all, you need to identify what are your boundary points. While you are defining a boundary point, suppose if I'm defining a boundary like this is a straight line. This is a straight line. Moving from point P1 to point P2, this is a straight line. If you know the coordinates of P1 and P2, you can define it by an analytical equation. You can define it by an analytical equation. The equation is like fx is equal to x1 minus x2 whole square plus y1 minus y2 whole square, and like that you can create an equation. But suppose if I have a figure like this, I have a boundary curve like this, how will you generate this mathematical equation now? Is it possible to generate this mathematical equation?
सर अगर उसको स्मॉल सब पार्ट्स में डिवाइड करें उस ज्योमेट्रिकल कर्व को, अगर ये नोन कर्व का फिगर अगर हम
यानी हम ये कहने की कोशिश कर रहे हैं, इट विल बी समथिंग लाइक अ स्मॉल पैच मल्टीप्लाइड बाय 50 टाइम्स.
यस सर.
This is what you are talking. This is what is actually done. What you are saying is actually very correct. This is how it is done. What you do is you start cutting this section into patches. This is one patch, this is another patch, this is another patch, then this is one patch. So you are cutting it into small sections. Each patch may actually not be easily reflected by a single curve. There may be some curves which may follow Coon's property, some curves may follow Bezier property, some may be B-spline curves, or some may be other curves like NURBS also. Non-rational B-spline curve, non-uniform rational B-spline curve. ठीक है. So, how many mathematical equations are you talking about over here? Huge, many.
Yes.
So you are making your own task very difficult. So in order to overcome a problem like this, half spaces was conceptualized. Half spaces is a concept. It is not a mathematical model. It's simply a concept. Now, what half spaces basically says that, suppose you make this cube. Suppose you are making this cube. Okay. So this cube will be within 3-dimensional Euclidean space. This boundaries will be within 3-dimensional Euclidean space. So what if I cut this cube into half? What if I cut this cube into half? Yani, rather than making this complete cube, let us assume this dimension to be 100 units. I'm not going into mm or something like that. This is suppose like 50 units. And like this is supposed to be again 100 units. Okay. Rather than making it like this, if I make it, this is 50 units, 50 units and 100 unit, a cube basically, a cube which will have the width of 100 unit, this 50 unit width, 100 unit height, but length of only 50 units. And on a plane, if I mirror that, what will I get? What will I get? If I make a cube, like this of L 50 units, W 50 and height 100, and on a plane, select a plane and mirror that. After that, what will I get?
So we are mirroring about a single plane?
Yes.
The length will get doubled?
So you will actually get the same object.
Yes.
Yes.
You will get the same object. Okay. So this was the concept that rather than taking an infinite Euclidean space, if I take a small Euclidean space and try to use analytical surfaces to create a model, then the model can be easily converted into an equation. That was the basic idea over here. So while developing the analytical models, the analytical properties or analytical features that we can use is line, curve, okay, or an arc. All these features can be used. But the problem with this concept is that if you start using simple things, there are some surfaces still which cannot be easily modeled, like a cone, like this cone. It's a converging cone. It's a converging cone. So even if I cut it at half section, the angle of convergence will not be equal because this circle are changing their dimensions. So there are many different complicated shapes like wind tunnel. If you want to create a wind tunnel, the wind tunnel is not going to be exactly similar at the center. It has a bigger cross section at one end and a smaller cross section at the other end. So if I start doing mirroring about a cross section, I'm not going to get an accurate shape out of it. So that is why this process was also not very successful, because mirroring always doesn't give you the exact answer to your solutions. The half spaces doesn't give you the exact answer to your solutions.
Sir, if we are able to find any particular axis, if it is possible,
Hey,
about
you
which we can mirror.
just I'll just give you one shape. Okay, I'm just giving you one shape. This is a typical wind tunnel cross section that you get.
Yes, sir.
Okay. This arc is generally same, but the problem is this is D1 and this is D2.
Yes, sir.
And the concept of half spaces is that you take a section at the center, you create this part and you mirror it across this section to get the other part.
Yes, sir.
The problem is this section is D2 and this section is D1. So if you mirror this, you will actually get D2.
Yes.
So again, you are going for transformations. If you want to convert D2 to D1, you need to go for transformation.
Sir, but I was asking that if we take a axis which is along the, longitude.
No. That is not possible. The concept is the half space. You understand? The concept is half space. Half space means the whole CAD model is to be broken into two sections at exactly half along the direction of modeling. So
okay, around that one. Yes.
Yeah, if suppose this is the direction of modeling that you are taking, so this is the plane that you have to select.
Yes.
But this figure is a what you call symmetrical figure.
Symmetrical figure. Yes.
But this type of a figure, this wind tunnel type of a figure, is not symmetrical in its length.
Yes.
Acha. One thing you can do, there is one thing that you can do. Rather than taking it along this length, you can take it along this length. Then you can make it by half space also. आप ये क्रॉस सेक्शन बना दीजिए उसका, ठीक?
Yes.
और इसको आप यहाँ पे एक्सट्रूड कर दीजिए. जैसे ये क्रॉस सेक्शन ये बनेगा, ये क्रॉस सेक्शन ये बनेगा, ये इसका कर्व बना, ये इसका कर्व बना. Rather than taking an axis along this, take a cut section along this axis.
Yes.
So now the problem, I hope you can understand the basic problem. The basic problem is which axis has to be taken in order to create that half space plane.
Yes.
Should it be along the length? Should it be along the width? So if you are not able to visualize this product along the width or along any other axis, you will be stuck. So the same thing is happening as happened in the previous method, that is primitive instancing, that you need to visualize the product very clearly before you even make a CAD model. The images should be very clear in your head what is being asked of me. So you will have 6 or 7 images front view, top view, side view, isometric view, all those images will be there in front of you. You need to merge those images together in your head and get a three-dimensional image in your head, and then think about doing the planing. That is the difficulty with this process. And that is why these processes were not very successful, because it required the person to be very conversant and fluid with graphics, as well as he should have a very good power of visualization. So I'm stopping over here. Tomorrow, next class I'll continue with the modeling.